going to be going over the law of sines. Now, if you have a triangle in a problem, you have to ask yourself, is it a right triangle or an oblique triangle? Now, if it's a right triangle, you're going to use the Pythagorean theorem or SOHCAHTOA. Now, if it's an oblique triangle, you're going to use the law of sines and law of cosines. Now, we're just going to focus on the law of sines for now. The law of sines is used for triangles with measurements and angles in the forms of angle, angle, side, angle, and side, side, angle. Now, these first two only have one answer, but the side, side angle ones can have 0, 1, or 2 answers to them, but we'll get to that in a moment. The formula for the law of sines is lowercase a over sine capital A equals lowercase b over sine capital B equals lowercase c over sine capital C. Now the triangle would be set up as shown, with variations to letter placement. All the capital letters A, B, and C are the angle measurements, while the lowercase letters are the side lengths. Now across from capital A would have to be lowercase a, across from capital B, lowercase b, so on and so forth. To solve a triangle with the law of sines, there must be one complete matching set, like capital A and lowercase a both having measurements, and one halfway filled set, like capital B having a measurement but not lowercase b. Now make sure to go to the mode on the calculator and switch from radians to degrees. That's very key here. Now an example for angle, angle, side. Capital A equals 85 degrees. Capital B equals 35 degrees. We don't have capital C. And then lowercase a equals 10 centimeters. You just draw your little chart here, have the capital letters and the lowercase letters. Now because we already have the a's, we can plug that into the formula. Lowercase a over sine capital A equals 10 over sine 85. Just plug those in. So we can plug those back into the formula. 10 over sine 85 equals lowercase b over sine 35, because we already have capital B, and equals lowercase c over sine capital C. We'll get to C in a moment though. Just focus on these two right here. You're going to cross multiply and get b sine 85 equals 10 sine 35. Divide each side by sine 85 to get b by itself, and you'll end up getting b equals 5.76. We're just going to round off the 2 decimal places. Now, everybody knows that in a triangle, it has to be 180 degrees in all. So we're just going to use that to find C. 180 minus 85 equals 95, then minus 35 equals 60. So therefore, capital C equals 60. Plug that back into the formula. 10 over sine 85 equals lowercase c over sine 60. Cross multiply again, divide again, and then lowercase c is going to end up being 8.69. And there you go. You have all your answers, and you've solved an angle, angle, side triangle. Now, next we have angle, angle, side, or angle, side, angle triangles. I'm sorry. Now, the only difference in that is just the fact that you don't have anything across from each other, I guess you could say. So therefore, you have to use that 180 trick. So up here, I have an example here. Capital A would be 30 degrees, capital B would be 70 degrees, and from there you can just 180 minus 30, and then 150 minus 70 equals 80. Now, because C already has a lowercase c across from it, 110, you just plug that back into the formula, easily get all your answers. Now, at side-side angle, which is the hardest part, really not that difficult though, it's just confusing. So for here, capital A equals 40 degrees, and lowercase c equals 130 meters. Lowercase a would be 90 meters, I'm sorry. So plug a's back in. 90 over sine 40 equals 130 over sine capital C. Excuse me. Cross multiply yet again. Excuse me. Divide each side by 90, and don't forget to use the sine -1 sign on the calculator. You have to press second and then sine. It's very simple. Use that and you'll get capital C equals 68.20. And here's the tricky part. This is possible that you can have two triangles, so you're almost always going to have to set up a chart here. So triangle number 1 and triangle number 2. Because we already have capital A, it's always going to remain as 40. Now, what you just got as C is 68.20. Now, for the opposite, for triangle number 2, I'm sorry, you're going to have to find the supplementary angle of 68.20, which is 111.8. So from there, you can solve with the 180 trick and get 71.8 degrees for b. Now on the other side would be 28.2 degrees for b. And so for lowercase b, you just plug everything back into the formula. You've already got a, plug in b, you'll end up getting 133.01. And then for the other triangle, 90 over sine 40 equals b over sine 28.2. End up getting 66.16. And there you go. There's your answer. That is your two triangles, and that is possible. Now, for number 2 here, you got capital A equals 45 degrees, lowercase b equals 128 meters, and then lowercase a equals 74 meters. Plug a's back in. 74 over sine 45 equals 128 over sine capital B. 128 sine 45 equals 74 sine capital B, and you'll end up getting, if you plug all this into the calculator, you're going to end up getting no solution. That is possible here. And that is possible. There's no triangle. And so for our third one, we have 70 degrees for capital A, lowercase c 45, and lowercase a 120 centimeters. You can plug all this back in. You're going to get your 20.63 equals capital C. You can plug this back into the formula, but the problem with capital C here is that the supplementary angle ends up causing this to be more than 180. So there is no other triangle. So there's only one triangle. You can end up putting all your problems back in, and you're just fine. You end up getting your final answer. So sum everything up. We've learned how to solve the sides and angles of angle sides, angled side angles, and side angles. We've learned the formula and its uses. Next time, we'll learn how to use the law of cosines.